Year 6, this is Wednesday's math lesson. This is the 13th of January and we're going to be thinking about writing equivalent fractions. So in yesterday's lesson we said as a challenge, could you try to start to write some equivalent fractions using your fraction rule? So now we're going to go into a little bit more detail with you about how you might like to use your fraction rule that you've drawn to find some more equivalent fractions. So Mrs. Stubbs has found all sorts of things in the maths cupboard. You may notice that somebody has stolen one of the tenths, so please ignore this. There should be a tenth here if you've got it. If you know where it is, let us know. Thank you. Now over to Mrs. Stubbs for some equivalent fractions.
Okay, so when we're writing equivalent fractions, we're looking for fractions that are equal. So if you remember in yesterday's lesson, I did point out one of the simpler ones, and I'm sure you already know this, that a half is equivalent to 2/4. Now I can use, if I haven't got the Cuisenaire or something, I can use my actual fraction wall, a paper copy of my fraction wall to show this. So here you can see that a half, there's the half, is equivalent, it's the same size. Look, here we are, here's the line. The rods, if you had the rods together, they'd be equal length, wouldn't they? The same size as 2/4 there. I've written a few more down. I've also got that a half is equivalent to 3/6. I'm going to use this fraction rule this time. I mean, obviously I'm lucky enough to have this at school, just to show you. Here we are, 1, 2, 3. They're the same size. Look, a half is equivalent to 3/6. And again, the eighths. Now, if I looked on my fraction wall, here we are, here's the half up here. I wonder how many eighths it would be. Let's have a little look. If you think you know the answer, you can be jotting it down or calling out at the screen. So here we are, 4/8, I think. Let's have a little look. 1, 2, 3, 4. 4/8. So I could fill that in. A half is equivalent to 4/8. And then we could look at how many tenths it is. Thankfully, that's not going to hinder us in any way. So let's have a little look. 1, 2, 3, 4. 5/10 is equivalent to a half. You might see a little sort of pattern here. Half is, it's 2/4, 3/6, 4/8. 5/10. I wonder if you can notice a relationship between the numerator and the denominator. If you can notice anything, you could probably, even without looking, work out how many 12ths it's going to be. And from that, you could also, actually, I've just noticed, I could write another pair. I could say that 5/10, because I've got this here, haven't I? Add to my list, 5/10 is actually the same as 4/8 because they're both a half. There's another pair of equivalent fractions. So what we'd like you to do is just to see how many pairs of equivalent fractions you can find. And you can use your paper copy or your own fraction rule that you've drawn in your book. A just slightly more complicated one, if you wanted to go a little bit further, is to find something like an equivalent for 3/4. If I just get my 3/4 out, here we are. Oh, there's 3 of them. 1, 2, 3. Okay. I could try and see perhaps how many eighths that would be. Just put that in there. So I'm not going to write the answer because you need to do some work. So see if you could work out or use your fraction rule to see how many eighths is equivalent to 3/4. So that's the first part. That's the main part of the lesson. Now, if you did this yesterday as part of a challenge, you might like to move on because sometimes you can actually work out an equivalent without using a visual aid, without using equipment or an actual copy of a fraction wall. Now here's where, and I think you may remember last term I keep saying how important knowing your times tables can be. I've written some equivalent fractions here. 2/3 is equivalent to 4/6. Now I wonder if any of you can see a relationship between these numerators and the denominators. Now you might notice, well, this numerator has basically doubled. All right, so that's been multiplied by 2. If I do the same to the denominator, I haven't actually changed the size of the fraction. They're the same size because I've multiplied the numerator by 2 and the denominator by 2. The fractions remain equal. Here, if we look at this one, now what's happened to the numerator? It's been times by 3. And here we go. The same has happened to the denominator. It's been times by 3. So again, these fractions are equivalent. I didn't need to look at a fraction wall or use these tiles. I can work it out from the pattern here. Now I wonder if you could work out the missing numerator here and the missing denominator here. Have a little look. Now these are the two I know. I know my denominators in this case. Have a little think. What has happened here? And once I've worked that out, if I do the same here, I will end up with an equivalent fraction. So I'll just fill this one in. 5, and again, I'm sure you know this, 5 times 4 is 20. So I've got to do the same to my numerator, so I keep it as an equivalent fraction. 4 times 4, and see how important knowing your tables is. 16. 4/5 will be the same as 16/20. And again, this one I've got to work out the denominator, so here we are. What's happened here? It's been times by 3. I'll have to squeeze that in underneath, I think. Times by 3. Let's do exactly the same to the denominator so that I get an equivalent fraction. 7 times 3, 21. There we are. So you've written equivalent fractions without having to look at the fraction wall. Now I'm sure some of you are going to pick this up really, really quickly if you haven't already. I've just got a page that we would maybe use if you were in school. Mrs. Ford's just going to zoom in on it. So maybe if you freeze the screen for a bit, you could see whether you could copy these into your books and find the missing equivalent fractions, the missing numbers. Sometimes you need to find the numerator. Sometimes you'll be asked to find the denominator. Now I'll just give you a little tip. If you always go back to this first fraction here, this might help you out. Okay, so you could look at what's happened here and the same needs to happen here. What's happened here and the same needs to happen here. Have a go. Any problems, we can talk about them in Zoom meetings. Good luck.